All right, so let's talk about Annuity Due. Now, if you have not watched my the part one of this, which is the ordinary annuity future value sinking fund, definitely go back and watch that. Okay, because you wanna make sure you watch that video first. This is a continuation of that video. So in this particular lesson, what we're going to cover is the annuity due, how to find the future value of the annuity due, finding the payment, the present value, and then common mistakes, and of course my key takeaways. Now, I want to make sure I reiterate, this video is not about the deep financial aspects of annuities. It's just how to work through the formulas and how the formulas work, future value for present value. If I need to do videos on that, I will. But for the sake of just for you to get through the assignment to see how it works, that's kind of what this video is for. So let's get into it. So these terms, the first three terms I went over in the first video over the ordinary annuity. So remember, go back and watch that one. But an annuity due is essentially, it's still an annuity. It's just the payments are made at the beginning of each payment period versus with an ordinary annuity, payments were made at the end. So with that said, payments are made at the beginning of each period. Some examples that I have here, like your insurance premiums, normally those are paid at the beginning before. You don't get your services and then you pay after. You cover your insurance for that month. You pay at the beginning. Monthly rent, lease, when you lease, I put a little fast car, and then like your magazine subscriptions, you pay at the beginning and then they send you the product. So that's kind of how it works. Still using compounding interest. So like the example here, I have 5,000 deposited at the beginning of each month, paying 3% compounded monthly. Remember, the frequency of your payments, you want those to match the frequency of the compounding. So that's why payments at the beginning of each month and then compounded monthly. Okay. So to find the future value of an annuity due, here is this formula. It looks very familiar to the ordinary annuity. You're subtracting one of the payments off and you're adding to the time period. Again, I can do separate videos that kind of talk about the difference between the two as it relates to the formula and why the formulas are this way. I won't be doing that in this particular video because this is strictly about working through the questions. So you have your payments. Okay, the payments are at the beginning of each period. Remember, your interest rate is your rate divided by the number of compounding periods. That's how you come up with I. And then your N is M times T, which is your compounding periods times the term of the annuity, however long it is, and that's what you would put in for your N. So let's do an example, okay? One sec. Over here on the right, I did a table like this on the ordinary annuity. So the difference with the annuity due is that the payments are made at the beginning of each. So like, let's say that we're depositing $100 at the beginning of each year for 6 years. You would start here. Okay, you would start at the beginning. So even though it says 0, this is really the beginning of the first year. This is the beginning of the second year. And so when you go through to find the future value, remember we talked about on the ordinary annuity video, we said the future value is just the sum of all of the payments, the deposits or payments, plus the interest they accrue. So if I wanted to find the future value of this particular payment, you would start here and then you would take the interest that accumulates at all of these. Well, that's what, how many years? 5? 1, 2, 3, 4, 5, 6. So that's 6. 1, 2, 3, 4, 5, 6. So that would be your 100 times. Let's say the interest rate was still 10. Go watch the other video and you'll see what I'm saying. Then that's what be for the end of year 1 or the beginning of year 1. And then the beginning of year 2, you would start here and then you would go 1, 2, 3, 4, 5. And so you would have 100 times 1.10 to the 5, and you would get that amount. So that's essentially what you would be doing. You would add them all up, and when you add them all up, you would get the future value. But because we don't feel like doing all that, we ain't gonna be adding up. If it's 10 years, 50 years, we're going to use the formula, right? They gave it to us. Let's use it. So let's look at this particular, let's look at this example here on finding the future value. So it says, let's say you deposit $800 at the beginning of each 6-month period for 5 years into an account that pays 6% compounded semi-annually. Find the value of the account. So 6-month period. Every 6 months, we know that semi-annual. That's why we have the semi-annually here. It's for 5 years. We want to find the future value. So my payments are $800, right? Let me get my notes so I can make sure I give you all the decimal places. So my payments $800. The rate, it says 6%, and we know that we convert our rates to decimals, right? Our compounding is 2 because it's semi-annually, 2 times a year. And our T is 5 years, almost put 6 years, 5 years. Okay, so far so good. Now remember the I, our I is R over M. So we have 0.06 divided by 2. 6 divided by 2 is going to be 3. So that's going to give us 0.03. And then N, that's your M times your T, your complete time period, which that's going to be 2 times 5, which that is 10. So that means there are 10 6-month periods in 5 years. Twice a year for 5 years, 2 times 5 is 10. Okay. So our rate now and our time period match the number of compounding periods. And remember, that's what we want. Okay, so I'm going to write this. Let me write the formula. And we're writing the formula just to kind of help us remember what it looks like. Again, I hope you have that you're taking a class that allows you to have a formula sheet, because when this particular math of finance section, there's tons of formulas. Okay, and sometimes they're hard to remember. A lot of times, if you can remember the future value for each one, then it's easy to come up with what the present value is. But anyway, all right, we have our pieces, right? We're going to use the payment, the I, and the N, right? Because we got the payment, the I, and the N. So that's what we need. So now let's determine the future value of $800 semi-annual payment. So 800, right? 1 plus, we're at 0.03 to the n plus 1. So to the 10 plus 1, that's going to give us, well, if I just go ahead and I'll do 10 plus 1, just so you can see it. Minus 1, right? Divided by 0.03. And then we subtract another payment. Hopefully I can do a video that shows the differences between the formulas, so you're like, why are you subtracting a payment, so that it'll make more sense. But we'll just keep going with this. All right, so now when we do the math, we have 800, and y'all know I'm going to show you every step, because some people prefer to see each steps, because some lectures, they skip steps and they automatically assume that you know, and you're like, well, I don't know. So that's why I do every single step. So 1 point, I'm doing this first. Okay, first I did this because it's in the parentheses. Now I'm going to do this, and after I do that, then I'll do the whole thing. Okay, so you get 1.38423387 minus 1 divided by 0.03, and then one of the biggest common mistakes is leaving this payment off. Okay, so just make sure you follow the formula. Even if you're doing it in your head or doing it in the calculator, don't at least write this part down. So as you're doing the math, you'll remember to subtract that $800. So sometimes people leave it off and they're like, why is my answer wrong? It's probably that part. 9 times out of 10 is that part. Okay, so now we have 800. When we take that minus 1, you just get 0.03 38,423,387 divided by 0.03. Subtract that payment off. When you not subtract, so now we're going to do the division here. When you do that division, okay, that's what I got. 12.80779,569. Okay. Don't forget to subtract that payment. So now when you follow order of operations, you want to subtract by 800 first and then do the subtraction, okay? So do that part first. You get 10246.23655 minus 800. And when you put that in your calculator, you get 9446.236553. And we're dealing with money. So when you round that 944624, 9446.24. Sorry, my little dollar sign. So the amount that ends up in the account at the end of 5 years after making semi-annual deposits of $800 is $9,446.24. All good? All good. Okay. Now on the screen, I just show you the beginning of it. So you have the work. The hardest part, getting all your pieces. I mean, if you don't mind taking the extra step to write that part down, especially the parts that you need, do that. And then the formula. That's the hardest part. And then plug and chug. Remember, I try to keep at least 8 decimal places, because if you round too soon, it throws the whole answer off. All right. So the same way we were able to find the payment, like how much do I need to pay, deposit every month, pay every month in order to find out what's going to be to get this amount at the end. Same thing here. It has its own formula. We do a little algebra on the future value formula, and you end up with the payment equals the future value times the interest rate divided by 1 plus the interest rate raised to the n plus 1 minus I. Now, the common mistake on this formula is forgetting to do the minus I, okay? Because everything else kind of looks the same, and it's like, oh, you still got to do that, okay? So let's do an example. Let's do an example on this one. And I showed you the work, but let me show you how I got to that, okay? Was this example number 2? Okay, so to save for a down payment for a home, Lisa's going to take money out of her paycheck. She's going to deposit it into an account that gives her 5.5% interest compounded monthly. She gets paid on the first of every month, so she's getting paid at the beginning of the period. That makes it an annuity due, so we can use the formula for that. And she wants to save $13,000 in the next 3.5 years for her down payment. It's good amount to save. How much should each of her deposits be? So how much should she take out of her paycheck to save every month so that she could have $13,000 at the end of 3.5 years? So I'm going to write down the pieces. So her payment we're looking for, but we do know that she wants to end up with $13,000, right? The account is paying a rate of 5.5%, and I'm going to go ahead and make that into a decimal. And this is over 3.5 years. What did I forget? Compounded monthly, and then 3.5 years. Could I have written it after? Yeah, but it is what it is. All right, so let's find our I. Remember, your I is R over M. So 0.055 divided by 12. When you take 0.055 divided by 12, that's when you get this. Okay, and that's what you see here. I went on ahead and did that. If your calculator allows you to leave it like this when you key it in there, then leave it like that. There's nothing wrong with that. And remember, on the last video I talked about, if your calculator has memory, like I use the TI-30X and it has like a memory, you can store these long decimals into the memory and then just use the memory keys to do the math. However you want to do it. Oh, and our n, remember our n is m times t. So that's going to be 12 times 3.5, 3.5, 3.5. So that's going to give you 42. Okay. And so I'll go ahead and I gave you the answer here, but let me go ahead and set up the formula. So payment equals future value times I. That way you can see what I did. 1 plus I to the n plus 1 minus I. Don't forget that I, okay? So, so this is what it would look like before converting everything. And if you want to put it in your calculator this way, there's nothing wrong with that. You could actually put in the 0.55 divided by 12 if it'll let you do that, okay? So this is going to be 1 plus 0.55 divided by 12 to the n plus 1. So 42 plus 1 to the 43, right? And then minus 1 minus the I. And so when you do it, this is when it looks like, excuse me, 1 plus 0.004 minus 1 minus 0. See, it starts to get like the numbers get so big. So yeah, if you can store it, definitely store it. Okay. So I won't work through this one. Well, I guess when you do the top, you should get, we'll just go ahead. What's that? 1, 2, 3, 4, 5, 6. That's what the numerator looks like. That's from doing this part. Okay. And then when you do the denominator, you get, what is this? 1.21729728 minus 1 minus. Okay. Just so you can see it. And then when you put all of this in your calculator, you get this. You get 0.21271,395. And when you divide that, you get 280,110,1316. And we're dealing with money, so that's how you get the 280.11. Okay? So easy peasy. Again, take the time to identify your pieces. Once you identify your pieces, okay, get the right formula, plug it in. Do not leave off that minus I. Throw it off, okay? Okay, cool beans. And then, of course, the present value. You can find the present value. What do I need to start with, okay? Its formula is also a little extra, okay? It's a little extra. So, yeah, we're just write down the formula. Okay, so let's do an example on that one. I think this is our last example because in the previous video I did more talking. So this one I'm just kind of showing you the formula. So, and of course, gave you the answer on this one too. Let me show you how I got what I got. So it says, if a Texas Lotto player wins the Powerball of $57.6 million, that would be paid out in 30 annual payments, and Texas can earn 5.1% interest. What is the cash value of the jackpot? So what I want to identify here, this cash value, That's the lump sum option. So when you look at when you're playing the lottery, a lot of times they're gonna say, "Hey, do you want to have annual payments, which would be some like a type of an annuity, or do you just want the money up front?" So there's like, okay, if you want the money up front, this is how much you would get up front. Otherwise, we'll space it out over 30 payments. So when they say what is the cash value, they're saying what is the lump sum option. So if you take 57.6 million and you divide it by 30, you get $1.92 million is what you get. So that's where that came from. So if you take 5.6 million, okay, that's what that looks like, right? And then if you divide it by 30, that's when you get Did I do that right? No. That's 576 million. Y'all, keep me honest. 5, 7. There we go. 1, 2, 3, 4, 5. Yeah. That divided by 30, you get that. Okay. So that's where that comes from. The 1.9 million. So this would be every year. Or they want the cash value option, which would be a total of 30 million. So you wouldn't get the total 57.6 million. You would just get the 30 million. Now you still got to pay taxes. That's still a thing. Here we're pretending like you're getting all of it because people are like, well, what do you want? What would you prefer? Would you prefer 30 million up front? Or do you want to get annual payments of at least $1 million a year? I think I would take the annual payments because, you know, you could spend some money. It would be hard to spend that much. No, I guess it wouldn't be hard to spend that much. Anyway, stay focused. Okay. So that's this would be the annual payments, right? And then when you plug it into the formula, so see I have the 1.92 million, 1.92 million, the interest rate. Okay, so let me show you that. So the rate is 5.1%. So that would be 0.051, right? And it's annually because they're doing annual payments. And the time is 30 years because there's 30 annual payments, right? So then your I, which is R over M, good thing it's 1, right? 0.051 divided by 1. So it's still 0.051. So that's cool. And then your N is M times T, which is also good because that's just 1 times 30 because it's once a year. So then that's 30. So that's where the minus 29 comes from. So you take the 30 minus 1. So you get the minus 29. Here's your payments. So the 1.92 million, 1.92 million. There's the interest rate. Okay. Not sure how much y'all want to see. If you know what, I'll just go ahead and write it so you can see it. So we already got this part on the screen. So I'll just continue from here. Okay. So y'all can see it. Yeah. So when you do that, the top part, this part here, okay, I'm going to do this becomes 1.051. Raise that to the negative 29. Okay, 1.051. You're going to raise that to the negative 29. So that's going to be 1 minus, I got 0.236333130. Okay. This numerator part here, when you do the subtraction, you get 0.763666870. Okay. Can I leave that? Yeah, we'll leave it right there. And then when you do this division, what did I get? Okay, I see it. You get that times 1,4,9,7,3,8,9,6,1,7. Okay, so for following order of operations, you're going to do this multiplication first and then do the addition second. Okay, do the multiplication first and then do the addition second. You should get 28749,880.65. Okay, and then when you add that together, I got 3669,880.65. And we're dealing with money, so and we'll just, it's millions. It's millions. So, would you rather have 30 annual payments of about 1.9 million, give or take a few? Or would you rather have 30 million up front? Okay, that's it. All right, that's it. So again, common mistakes. Convert your percents to decimals. Okay, don't forget to convert to decimals. Make sure that your payment periods match your compounding periods. Those need to stay in sync. Knowing which formula to use, but not only knowing which formula to use, don't leave off those key, the minus payment on the, what was that, the present value one or the payment one? Don't leave off that minus payment on the present value, and then don't leave off, no, on the future value, don't leave off the minus payment. And then on the payment formula, don't drop that I. Okay. Just write it down. Write it down. Hopefully, again, you have a class that allows you to write those down and then keep at least 8 decimal places. You don't want to round too soon. Trust me. Trust me. Okay. Key takeaways are just the formulas. Okay. Don't magically drop that off. Don't magically forget about the I. Do your conversions. Okay. If, like I said in the work, if you don't mind, I know some people are saving paper for some reason. Write down the pieces that you know. Okay, write down the pieces that you know. Let me go up to this one. Make sure you write down the formula. Just write down everything you know, and then if everything else is in your calculator, do what you got to do. Now, unless your instructor wants to see your work, then that's what we've done here. We've kind of went through the steps to show the work, which is good, so you can see what's going on. Again, you can hire a CPA, all that to do it for you, but at least you'll have an understanding behind the scenes what's going on. All right? Complete your assignment. Do well. Write things down. And if you have questions, reach out because I'm always here to help. Okay? All right, y'all. Make it a good one. Bye.